Chapter 3, Parallel and Perpendicular Lines. And now what we're going to do is we're going to practice graphing lines, but now we're going to focus in on graphing parallel lines and perpendicular lines. All right, so if you remember back to your algebra, we have a relationship for parallel lines. So if I know that two lines are parallel, then what I know is their slopes have to be equal, exactly the same. So if I look here, it says, what would the slope of the parallel line be if the slope is -3? Well, the slope of the parallel would also be -3. Here, they give me an equation in slope-intercept form. Remember, my slope of my original is 2/5. So the next question, what's the slope of the parallel? And that would also be 2/5. Now we look at the slopes of the perpendiculars. Sorry, excuse me. So the slopes of the perpendicular lines. The slope of perpendicular lines are either what we call negative reciprocals or opposite reciprocals. Now, what does that mean? So what it means is two things. Remember, the word reciprocal means you multiply by the inverse. So we take the fraction and we flip it. So instead of 2, it becomes 1/2. Instead of 3/4, it becomes 4/3. Reciprocating just flips the fraction. Then we want to change the sign of what is there. Okay, so if we look at this, we have the slope of a perpendicular line B if the slope is a -3. So the slope of the perpendicular then, remember -3 is -3/1. So we change the sign of that, which would make it from negative to positive, and then we flip it. So the slope of the perpendicular would be 1/3. Here, the slope of my original is 2/5. So the slope of the perpendicular, we change the sign so it'd become a negative, and then we flip the fraction to 5/2. Okay, so now that we know the relationship, we start taking a look at the line itself. So if I start off and I said I want to pass through the point 5, -5. So the first thing I'm going to do is I'm going to go to 5, -5, and I'm going to put a point in there. Now, and I want it parallel to this line. So the only thing I'm concerned about with this line is the slope. So the slope of the original is -4/3. So if I want the line parallel, it is identical. It has to be equal. So my slope would also be 4/3. So when we look to graph it now, I would either go down 4, 1, 2, 3, 4, right 3, or I would go up 4, 1, 2, 3, 4, left 3. And here is the line that is parallel to the given line going through the point 5, -5. Now, just to prove that to you, I want to graph this line. So this line is a slope of -4/3 and a y-intercept of -1. So I'm going to start here at -1. I'm going to go down 4, 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. Now, when you look at this blue line, okay, if you think of it, would those two lines ever cross? And the answer is no, and here's why. When you look at the slope, remember the slopes are the movement, how it's moving. So on the red line, I'm moving up 4, left 3, up 4, left 3. On the blue line, I'm moving up 4, left 3, up 4, left 3. So they're moving at the exact same rate of change. If you think about it, let's use cars as an example. If I start off with two vehicles, and the first car is, let's say, 20 feet ahead of the second car, and these cars are traveling at the exact same rate of speed. So let's say they're both traveling at exactly 50 miles an hour. If the first car is 20 feet ahead of the second car, and they're traveling exactly at 50 miles per hour, will the second car ever reach it? And the answer is no, because they're traveling at the exact same speed. Same thing here. These two lines are moving at the exact same rate of change, the same slope. So even though they're never touching, they never will touch because they're continuing to move at that exact same rate of speed. That's why we can guarantee that they are going to be parallel. As long as the y-intercepts are not the same, then they will just continue to go on to infinity, both directions, and never touch. Okay? Let's try another one. So on this one, we're going to go perpendicular this time. So the first thing I'm going to do is I'm going to plot my point. 1, 2, 3, up 1. Okay, so here I've got my starting point, -3, 1. Now my slope of my original is 4. So now I look, what is the slope of the perpendicular to that? So if we look, remember we change the sign and we flip it. So it'd be a -1/4. So that means I'm going to go up 1, 1, 2, 3, 4 to the left, down 1, 1, 2, 3, 4 to the right. I connect those lines. I connect those points with my line here, and there is my line. Now, just to show you our perpendicular, remember our perpendicular, the slope is 4, has a y-intercept of 1. So if we go up 1, and now I'm going to go down 4, 1, 2, 3, 4, left 1, or I'm going to go up 4, 1, 2, 3, 4, right 1, you can see that those two lines are going to intersect at a right angle, which would make them parallel. Okay? All right, let's try another set just to make sure we got this. So first thing we're going to do is we're going to start off here, 5, -5. And this time I want perpendicular. My original slope is 5/3. So the slope of the perpendicular, remember we changed the sign, we flip the fraction. So now I'm going to go up 3, 1, 2, 3, left 5, 1, 2, 3, 4, 5. And if I want, I could do it again, or I can go down 3, 1, 2, 3, 1, 2, 3, 4, 5. At that, I connect them, make that line nice and straight, and there it is. If we want to double check ourselves, my slope of my original is 5/3. My y-intercept is -3. So I could come in here at -3. From there, I'm going to go up 5, 1, 2, 3, 4, 5, 1, 2, 3. 1, 2, 3, 4, 5, 1, 2, 3. I can connect those, make that line nice and straight, and you will notice they are coming in there at a right angle, making them perpendicular. Okay? Now, the next thing we have is the slope formula. Remember this back, given 2 points, x of 1, y sub 1, and x of 2, y sub 2. The slope of a line passing through the points will be at y sub 1 minus y sub 2. We take the two y values and subtract them. We take the two x values and we subtract them, and then we simplify the fraction. Now, remember what we're looking for is we're looking for whether these 2 points would cause them to be parallel, perpendicular, or neither. So I have 2 lines here. So if I look at line 2, on line 2, my slope is attached to the x. It's written in slope-intercept form, and that is -2/3. The slope of line 1, I actually have to find. So I've got -5 minus my other y value, 1, over, since I used the -5 first, then I have to use the 2, minus -2. So -5 minus 1 is a -6. 2 minus a -2 gets me a +4. I simplify that fraction, and that is going to give me a -3/2. Now, what relationship are they? Well, first thing, I know they're not parallel. Why? Because they're not identical. They're not equal. Second thing is I see that they're flipped, but they are both negative. So that throws out perpendicular, so the only option left has to be neither. They are the reciprocals of each other, but they did not change the sign. Okay? Let's try another one. So here, I have a set of ordered pairs, so I'm going to find line 1 here. So I'm going to start off, this time I'm going to take the -3. So -3 minus 2, since I started with the -3, I'll start with the -6 minus -4. So -3 minus 2, that's a -5. And then add it, that's going to get me a -2. Negative divided by a negative is a positive. So the slope of line 1 is 5/2. Now we come over here. In order to find the slope here, I need to do some solving. So the first thing I'm going to do is I'm going to minus the 10x from both sides. Then I'm going to divide everything by a -4. And at that now we would have y equals -10 over -4. So the negatives cancel, simplify the fraction. And to be honest, we could care less about the y-intercept. So when we look at that, we have 5/2 and 5/2. So we would say those lines are parallel. Why? Because their slopes are exactly the same. Okay, let's try a third one now. So we're going to start off with line 1. I'm given ordered pairs, so I'm going to just use my formula. So I'm going to go 4 minus 0. And then since I used the 4 first, I'm going to use the 2. So 4 minus 0 is 4. 2 minus 1 is 1. So that gives me a slope of 4. Over here on the second one, I'm going to solve it for y. So I'm going to start off by subtracting the x from both sides. Then I'm going to take and divide by the 4 to everything. And again, we honestly don't care about the y-intercept per se. So I have -1/4 x plus 23/4. So my slope of line 2 is -1/4. So when I look at those, the signs changed and they flipped. So that means they would be perpendicular. Okay, and that is how we determine parallel, perpendicular, or neither, and how we graph lines that are parallel or perpendicular.